Hi guys, welcome to lesson 11.2b, dividing rational expressions. So our objectives for today is that I can divide rational expressions and that I can simplify complex fractions. So we're actually going to get to the simplifying complex fractions today. So you can multiply and divide rational expressions using the same properties that you use to multiply and divide numerical fractions. So what was that strategy that we used when we divided fractions?
Keep, change, flip.
So we need to
Keep, change, flip. Keep, change, flip.
Otherwise known as multiplying by the reciprocal. So we are going to keep our first fraction, x over x plus y.
Change.
We're going to change it to multiplication, and we are flipping our second fraction. X plus y is now going to be over xy.
Over, under.
Okay, now we just need to cancel out terms that are going to cancel. And I'm left with 1 over y. My excluded values, I actually didn't include it because we have multivariables on this one. Can't have 0. We can't have, well, that x plus y is so dependent on all kinds of other things.
Whatever.
Yeah. All right, letter B.
Keep.
Keep, and when we keep it, we can write it as a factored form right away. So we have 4 times the quantity, x plus 2, over 2 times the quantity, 3x minus 5. Change it to multiplication, and now we're going to flip it. So 9x minus 15, we can factor out to 3 and x minus 5. X squared plus 6x plus 8 is going to be x plus 4, x plus 2. And now we cancel. So that was actually 3x minus 5 when we pulled the 3 out. All right, so now we can cancel the 3x minus 5s.
Thank you.
And we can cancel the x plus 2s. And we can reduce 4 over 2 and make that 2 over 1. And it looks like that's all I got. So now we multiply across the numerator. 2 times 3 is 6 over x plus 4. Okay. And our excluded values for this one would be x cannot equal -4, -2, positive 5/3. And then here's where things get kind of messy because originally, you have a 3x minus 5. Actually, no, that would be the same. Never mind. We're good. All right. Complex fractions, when you start doing rational or excluded values, can get really tricky really fast. Because even something that's in the numerator of your denominator fraction would make it 0. And so, yeah, I'll let your brains think about that for a little while. So x squared minus 36, difference of perfect squares, x plus 6, x minus 6. 9x minus 18 factors out to 9 times the quantity x minus 2. X squared plus 15x minus 14 is x plus 7, x minus 2. And x plus 6 remains in its state. So we cross out what we can. X plus 6 over x plus 6 cancels out. X minus 2 over x minus 2 cancels out. And we are left with x minus 6, x plus 7 over 9. We can plug in some excluded values here. We've got 2, we've got -6. We would also have -7 and positive 2. So anything that would make that second fraction 0 would be a problem. So, all right. 25x squared minus 36, difference of perfect squares. 5x plus 6, 5x minus 6. You think I want them to know that rule?
It's kind of looking that way.
Yeah. Over 56x. Maybe they'll take the hint. multiplied by, well, we've got 8x in the numerator and 5x minus 6 in the denominator. So now we need to cancel. Our 5x minus 6's cancel out. Our 8x is going to reduce to 1 over 7x. And so we're left with 5x plus 6 over 7x. X cannot equal 0. X cannot equal positive 6/5. Okay. Problem number 5, dividing a rational expression by a polynomial. We want to know what is the quotient, not product, and state any excluded values. So, remember, polynomials are just over 1. So we have x squared minus 2x plus 1. So that'll be x minus 1, x minus 1. And x squared plus 2, can we do anything with that? No, we can't. Mr. Bolin was trying to trick you and see if you thought that was difference of perfect squares. It's a difference, and it's not a perfect square. All right, and then we've got 1 over x minus 1. X minus 1's cancel. We're left with x plus 1 over x squared plus 2. Okay. Excluded value would be 0. No, not 0.
Oh,
it would be plus or minus the square root of 2 and 1.
So do you want them to state
You guys do not need to state excluded values for these, because they get messy, like I said. All right. Remember, our polynomials are over 1. So we have 8x cubed minus 8x. So we can factor out an 8x, and we're left with x squared minus 1 over 4x. And our polynomial, x squared, it's going to be 1 over. We're looking for factors of 4 that add up to 5. So that'll be x plus 4, x plus 1. But what is that I see?
Man.
X plus 1, x minus 1. Haha.
Got me.
Yep. All right, so our x plus 1's cancel out. Our 8 over 4 reduces to 2 over 1. 8x and 4x, 2 over 1. And that looks like it's all that I can cancel. So I'm left with 2 times the quantity x minus 1 over x plus 4. Okay. All right. Complex fractions. Fractions within fractions, kind of like Inception. All right. So Dreams Within a Dream. Great movie. Anyways, moving on. 1 over x plus 4 over 2x squared over 2x plus 8.
I'm going to write this a little bit different so my brain understands what's going on here.
Okay.
Because once it looks like that, then it's the other problem.
Mm-hmm. Yep.
So keep, change, flip. So keep, change, flip.
And we can factor out 2. We're left with x plus 4. X plus 4s are going to cancel out. Our 2's cancel out. And we're left with 1 over x squared. Okay. All right, letter B, do the same thing. So Ms. is rewriting it as 1 over x plus 4.
I'm going to try to do this.
And she's going to do it
all in one
shot.
step.
So x squared minus 16, difference perfect squares, x plus 4, x minus 4, and x minus 3.
Whew.
All right, so cancel out what we can. X plus 4 and x plus 4 cancel. And that looks like it. So we've got x minus 4 over x minus 3. Okay. Letters C and D, why don't you guys try on your own, and then we will go over them. So 1 over x minus 3 stays the same. We're going to flip the other one around. So we're going to have x minus 3 over 3. X minus 3's cancel, and we reduce to 1 over 3.
These are kind of fun, Bolander.
Yep.
Uh-oh, I spoke too soon. Spoke too soon.
All right, so we've got n times the quantity n plus 2 over, we're looking for factors of 18 that add up to 9. Well, that's going to be plus 6 and plus 3. We're going to multiply by, we're going to flip it, so we're looking for factors of negative 30 that add up to positive 1. So that'll be n plus 6, n minus 5. N squared minus 5n is n times the quantity n minus 5. All right. Now we just need to cancel what we can cancel. So n plus 6 cancels out. N's cancel out. N minus 5 cancels out. And we're left with n plus 2 over n plus 3. All right. Blast from the past dimensional analysis. Yay! In November 1996, NASA launched the Mars Global Surveyor. It took 309 days for the orbiter to travel 466 million miles from Earth to Mars. What was the speed of the spacecraft in miles per hour round to the nearest hundredth? All right, so our speed is going to be distance divided by time. Our distance is 466 million miles. Over 309 days. And we want to know its speed in miles per hour. So we just need to convert days to hours. So 1 day is 24 hours. And all we got to do is do our division. Well, multiply across and then do the division. So we have 466 million.
Over
309 times 24. Did I not write that down?
You didn't.
Okay. 309 times 24 is 7416. And you get 62837.109 miles per hour. So 62,837 miles per hour.
I hope NASA appreciates you, Mr. Bolin.
They do. Hey, at least I haven't screwed up metric and US conversions, which is the reason why we lost the Mars Climate Surveyor, because the hardware was built in standard units and the software was written with metric, and it crashed into the atmosphere. So that is why now all NASA spacecraft, everything about it is done in metric.
Always should have been.
Always should have been. So level of understanding, make sure you circle it, tell me where you're at. Identify any questions or confusions you may have from the lesson, and write down your summary. See you all in class.